Hey everybody, it's Mr. Field here. My camera is a little slow, but I don't think you really care about that. All right, so we're going to talk about proportions and similarity. Again, I am grieving a little bit, away from, being away from quadrilaterals. I really enjoyed that, but it's time to move on. Okay, so we are going to skip section 7.1 because it's ratios and proportions, and you should already know that. That doesn't mean that the things in section 7.1 are not important. It's just that you should already know them, so we're not going to spend class time on them. If you look at that section and you find questions that you say, wait a minute, I don't know this, definitely put it in the organizer, because I'm just not teaching you, because I think you already know. We're going to talk about similar polygons, and that is, I love it, same shape, not necessarily the same size. That is my definition too of a similar polygon. Let me see if I can open this in Canvas. All right, that saves the annotation. Let's see if that works. And while I wait for it to load, same shape, not necessarily the same size. Also, we're going to talk about similar triangles, which have theorems kind of like congruent triangles. So that will be fun. Let's look and see what we have to start with here. Fibonacci. Okay. So the first thing is the okay, so first thing we gotta say, very important. Corresponding angles are congruent. Corresponding sides are proportional. That means when you divide them, all the ratios are the same. Okay? So we'll be dividing sides and we'll be comparing angles. And then we can write a similarity statement, which is right here. All the corresponding angles are in the same position in that triangle or polygon. All right, so in the diagram, NPQR is similar. That's the sign for similar. You just cut out the equal sign because they're not the same size, but they are the same shape. List all the pairs of congruent angles and write a proportion that relates to the corresponding sides. All right, I can do that. Angle N is congruent to angle U. See? Angle P is congruent to angle B. And I'm just going to dot, 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 because I think you can say Q and S and R and T. The proportional statement is this: NP right here divided by ST. If we divide those two sides, it will be equal to PQ divided by TU. Oh, SV. Notice these are corresponding sides. And NR can be divided by TU, and RQ can be divided by ST. So I said NP, but I meant VU over here. All right, so they really turned that thing around. So you see, this is the proportional sides. When we divide them, we get the same number in each ratio. We don't generally put all four. We usually use 2 at a time. There can be some cross multiplying because we have a fraction equal to a fraction. And yeah, another way you can think of it is a scale factor. So when you take a picture and make it bigger or smaller, that is a scale factor. If one is twice the size or something, that's similarity. Determine whether the triangles shown are similar. If they're similar, we just said it. All angles must be congruent and all sides proportional. That's what we're checking for. So let's see if it's true. Are all the angles, so we have angle N is congruent to angle R, that's good. Angle Q is congruent to angle S, that's good. And so we know that P has to be congruent to T. So we have all congruent angles. So now let's look at all the sides proportional. So 12.5, what would we divide that by? NQ, that's going to be divided by 10. And I know that because 12.5 is in between the 1 and the 2, and 10 is also in between the 1 and the 2. So they are corresponding sides. So what I'm going to do is I'm just going to actually divide 12.5 by 10, and I know that's 1.25. And I'm going to also, and then we're going to do 15 divided by, so that is the 1 in the other side. So that's 12. And 15 divided by 12 is also 1.25. And then we're going to do 11.5 divided by 9.2, and that is also 1.25. So because all the ratios have the same 1.25, all sides are proportional, the triangles are similar. All right, so then we can use the similar figures to solve for x and y, or missing side ratios, once we know that they're similar. So here we're told these two triangles are similar. So that JL must be corresponding with SQ. So we know that J 3y over minus 2 over 5 is going to be equal to, well, now this is on that one has the 2 and then the missing side. So we need the 2 with the missing side. So we got to put it over 3. So you got to be kind of careful when you are identifying your corresponding sides. And I have been looking at the pictures. But another way I could have done it is by looking at the similarity statement. So the corresponding sides from the similarity statement, JL would be over QS. LM would be over ST. So that's probably an easy way. And JM, first and third, over first and third QT. So if you're not sure when you look at the picture, it looks deceiving, then you can use the similarity statement if you have. Once you have them set up, then we're just going to cross multiply. All right, cross multiply because we have a fraction equal to a fraction. We have 3 times 3y minus 2 is going to be 9y minus 6. And then 5 times 6x minus 3 is 30x minus 15. And then we are going to, oh no, we have an x and a y in our proportion. So unfortunately, I shouldn't have used the x and the y, because we have the other numbers. We actually have all the numbers. So I should have used JM and QT. So let's just go over here, take 2. JM and QT is going to be 4 over 3. But at least I figured it out before I was done. And so now I can set that equal to 1 at a time. So how about 3y minus 2 over 5? And now I'm just going to have 1. But, I did not look at this. And then we solve for y. And then separately over here, we could do the 4. 3 equals to 6x minus 3 over 3. Cross multiply and solve for x. Okay, so I'll leave that you guys to do that. Okay. So the perimeter. Now here's the thing. We have a theorem 7.1. If two polygons are similar, then their perimeters are proportional. That means if you divide their perimeters, it would also be the same number, just like we got the 1.25 earlier. So find the scale factor of MNPQ to X, Y, Z, W, and the perimeter of each polygon. Okay, so I'll find the scale factor. Then I'll just let you know how we would find the perimeter. If you want to do that, you can post about it in the organizer, because I know everybody's going to post in the organizer, even though they didn't last week. It's going to happen this week. Why don't you pause the video and do that right now? Okay, so WX is similar to QM. You see how I did that? So we know that 4/8 is our ratio. And so that reduces to 1/2. That means that this one is half the size of this one. Or we could say it this way. You take that one, you multiply it by 2, and you get that one. Oh, so I will find the perimeters nice and easy. So we're just gonna add. I'm gonna add all those together. 17 and 17 is 34. And then if we divide the 34 by 2, we get 17. So the perimeter of this one is 17, because the perimeter of this one is 34. And we know the scale factor is 1/2. 17 is 1/2 of 34. Okay, so now we got to do 7/3. You may be thinking, can we just stop at 7/2? Now we got to talk about similar triangles. So we have, like I was saying earlier, we have angle similarity. So we don't actually have to know all the angles and all the sides. If we just know that we have two congruent corresponding angle pairs, we know the triangles are similar. Make sure you write that down. So are these two triangles similar? Well, let's see. What is the measure of angle G? 90 plus 47 is 137. Subtract that from 180, you get 43. So it checks out. They are similar. They have all the same angles. Now here we have parallel lines. So you should be thinking we have corresponding angles. And we have corresponding angles there. So they are similar because of the CAP, the corresponding angle postulate. That is not going anywhere. Okay, side similarity. If we know all the side lengths, all 6, then we can divide them and find that they all have the same ratio. The triangles are similar. And also side similarity. If we have 2 side ratios and an included angle that is congruent, then we know the triangles are similar. All right, so there's a proof. Don't worry about that. So are these two triangles similar? Well, let's take we'll take the two biggest sides, 16 and 12. Then where's the medium sides? 12 and 9. And then the small sides, 8 and 6. And we'll just divide them. 16 divided by 12 is 1.3 repeating. 12 divided by 9 is 1.3 repeating. And 6 and 8 over 6 is 1.3 repeating. So are these triangles similar? Yes, by side similarity. And then of course this one we can see the vertical angles there. And we can do 10 over 20. And we can do 22 over 11. And we can find that 11/22. And we can see that they are both 1/2. We have two corresponding side ratios that are equal, both 1/2. And we have the angle in between them that is congruent. So those are congruent by similar by side angle side similarity. The reflexive, symmetric, and transitive property hold true for similarity and parts of similar triangles. Okay, you can see that we can set up some other ratios, like this one would be 5/x equals 6/3 3/5. And then we would cross multiply. This we can set up x plus 6/2x plus 6 equals 8/10, and then cross multiply. So knowing parts of similar triangles help us. And my favorite one before we're done is indirect measurement. You can take similarity and you can measure things using shadows. Hopefully it'll be warm enough that we can use the shadows outside and measure some objects that are otherwise not measurable. Okay, so Adam is standing next to the Paul Mileto building in Columbia. Adam is 6 feet tall. Wow. So he's 6 feet. And the length of his shadow is 9 feet. So we see a right triangle there. The length, the building shadow is 322.5. And then we want to know how tall the building is. Then we can set up x/6 equals 3. It just stopped. 322.5/9, and you would cross multiply. All right, so that is from the book. And then also make sure that you start P1 through 5, and I will see you in class with all those wonderful organizer posts made. Bye, everybody.